Greetings everyone, let us now study the factorial notation. Now in our study of sequences, we will encounter factorial notations. It is important to know how to calculate them and to simplify these factorial expressions if possible. Okay, so we have right here, if n is a positive integer, the notation n factorial is the product of all positive integers from n down through 1. So what does that mean? So we have right here n factorial is equal to n multiplied by n minus 1 times n minus 2 times all the way to 3, 2 until we reach 1. Okay, so that's what the factorial symbol means. Okay, we will have some examples later. And a 0 factorial by definition is equal to 1. So that you have right here. Okay, so let's get the factorial of the first few positive integers. Let's say 1. Start with 1. 1 factorial is 1, right? 2 factorial is equal to 2 times 1 is equal to 2. And 3 factorial is equal to 3 times 2 times 1 is equal to 6. 4 factorial is equal to 4 times 3 times 2 times 1 is equal to 24. Okay, now you get the idea and proceed following the pattern. Okay, now let's have an example where we actually have a general term that has a factorial expression. Okay, we have here example 1. Example 1. Okay, so write the first 4. Write the first 4 terms of the sequence. Terms of the sequence whose nth term is, okay, let's go down. An is equal to 2 raised to n all over n minus 1 factorial. There you have the factorial symbol. Okay, it asks us to generate the first 4, so let's do just that. So write our solution here. Okay, so a1, so 2 raised to 1 all over 1 minus 1 factorial. That will be 2 all over 0 factorial, and we know that 0 factorial is equal to 1, which is equal to 2 over 1, which is equal to 2. How about a2? Okay, so we will have 2 raised to 2 all over 2 minus 1 factorial. We have 4 over 1 factorial. So 4 over 1 and then equal to 4. Okay, second term. And for the third term, we have 2 raised to 3 over 3 minus 2 factorial. We get 8 all over, I'm sorry, this is 3 minus 1. 3 minus 1, right? This is 2 factorial. You'll get 8 all over 2, and then you'll get 4. Okay, let's proceed to a4. We get 2 raised to 4 all over, do we get 4 minus 1 factorial. You'll get 16 all over 3 factorial, and so 16 all over 3 times 2 times 1, we get 16 over 6. If we simplify this, we get 8 all over 3. So these are our answers. You have 2, 4, 4, and 8 over 3. Okay, so that's how you evaluate that type of problem. Now we can also simplify a factorial expression if there are factorials in the denominator and the numerator. Okay, so let's say for example, so example number 2 here. Please wait. Say for example we have 10 factorial all over 2 factorial times 8 factorial. Okay, So how do we simplify this? So as we know, we can express 10 factorial as 8 factorial times 9 times 10, right? This is right? Divided by 2 factorial is 8 factorial. We can cancel 8 factorial out. And then we know that 2 factorial is 2. And then we cancel that. I have 5 right here. And then you will get 45. Okay? So that's how you simplify the factorials. So let's say we have another example here. Let's say we have n plus 1 factorial all over n factorial. Now, we can express this n plus 1 factorial by, we can rewrite this as n factorial multiplied by n plus 1, right? And then divided by n factorial. So, you just cancel the n factorial and you will be left with n plus 1. So if you want an example, if you want to substitute numbers for this, let's say it's just like saying 9 factorial all over 8 factorial. So if you want to substitute numbers, then you will get this is equal to 8 factorial, and then we have times 9, right? All over 8 factorial. You can cancel this out, you'll get 9. So that's the same thing. Only in this previous example, we have variables instead of numbers. Okay, so that's how you evaluate factorial expressions. So if you see a general term with factorials in the numerator and the denominator, don't forget to simplify it first before evaluating it, because it can make your life easier. Okay, so thank you for watching, and I will see you in the next video.